This is a worked example on how to solve an inequality involving a polynomial. Now, I am going to start this problem with the polynomial already factored. If you want to understand how to factor this polynomial or see the worked example, the previous QR code on this worksheet, the previous worked example, uses the exact same polynomial function. So you can actually go back and watch that video to find out how to factor it. But in this example, I'm going to start with the factored version just to save time. So right off the bat, the first step to actually solving a inequality with a polynomial is you want to factor it. So even before that, you would want to move all terms to one side. So for example, if I had, say, this as my inequality, you would want to start by moving everything to one side. So you would turn it into this equation, and then you want to factor everything. So get everything to one side, you compare it to 0, then factor. But what I really want to focus on in this video is how to construct the sign diagram, because that's the new unique thing about inequalities. If you have factoring down, then that step should be taken care of. If you're not quite comfortable with factoring, I suggest that you go and look at some of the earlier problems in this worksheet before moving on to this one. But without further ado, let's talk about how we would interpret this factorization into making a sign diagram. So I factored my polynomial and I have it compared to 0. So what I want to write down all of the specific zeros that are produced by this factorization. So for just a moment, you want to pretend that this is equal to 0 and then write down all of those factors. So from these factors, I have an x equals 1, an x equals -2, and an x equals +3. And so now what we can do is we can draw out our number line, and we're going to write down these areas of interest. So I can draw hopefully a straight line. Yep, there we go. And then put arrows on each end, and now I can label each point of interest. So the first one is -2. That's our smallest value. Then we have +1. Then we have +3. Okay, so this is going to be very similar to how we did sign diagrams with quadratic functions, but I will still try and cover this in as much detail as possible. And I actually want to give myself a good bit of room to work here. So let me scroll down a bit. Okay, so what we want to do is we want to go through every single point and analyze sort of what is going on. So let's look at the -2 first. So I'm going to do -2 in blue. So I'm going to look at this point of interest, -2, and I want to ask myself, what kind of line produced this point? It's a positive linear line, and what I'm going to do is I'm going to draw this line through -2. So I can draw this positive linear line through -2. And we want to think just for a moment, what is this conveying to us, right? I don't actually care what x minus 2 looks like on a graph. This just has to be positive and linear. What we're really trying to describe is the idea that if you just focus on the equation x minus 2 as a line on a graph, any value of x that is greater than -2, that line's going to produce me a positive value. And any value of x that is less than -2 on that number line is going to produce a negative value. I don't necessarily care what those values are. I just care that they are either positive or negative. So let's look at another value. We have x equals 1, and this was produced, again, by x minus 1, which is a positive linear line. So I can again draw a straight line through this point. Okay, let me try and draw this more accurate. Oh boy, okay. All right, yeah, there we go, that's fine. So my positive linear line, and again, we're not super worried about the angle, right? I could draw these super steep, super shallow. What I'm trying to convey is that on the line x minus 1, if x is greater than 1, everything's going to be positive, and if x is less than 1, everything's going to be negative. And then the last line we're going to draw is x equals 3. And I can draw a line through this. Let me try and make that more accurate. Okay, whatever. Good enough. Okay. So, again, it might look a little steeper, a little different than the other lines, but that really doesn't matter. All we're trying to convey, any value less than 3 on that line, x minus 3, is negative. Any value greater than 3 is positive. Now what we want to do is we want to split this interval into its different sections. So I can kind of draw a dotted line down the middle here. I can draw the dotted line down the middle here. And down the middle here. And so you want to look at each interval I've drawn. So I have 4 of them. I have this interval, this interval, this interval, and this interval. And we want to look at what's going to happen in each one. So in each interval, let's just pretend that we're picking a sample point, right? I don't actually care what this point is. I don't care about naming it -3. I don't care about, defining it. I'm just saying that this point is less than -2. And then I want to see what kind of value is produced by all of my lines. So if I start moving downward, I can see that this point is going to be captured by the negative portion of my blue line. And if we keep moving downward, and keep in mind that these straight lines are going to move on forever, this green line is going to capture my point, again at a negative value. And while I'm going to not really have enough room on my screen, this red value keeps going on forever. And if I go down far enough, this point I've picked is going to be captured by a negative portion on the red line. And because all of my lines have produced a negative value for this sample point, and again, I don't necessarily know what those values are, but what I do know is that each line produced a negative, and 3 arbitrary negative values multiplied is going to be a negative value. Because 2 negatives multiply to a positive, I then get positive times a negative, and that equals a negative, right? So I'm going to label this whole interval as negative, right? Negative times negative times negative is a negative. Okay, let's look at another interval. So this spot right here. If I start traveling upward, I can see that the blue line is going to produce me a positive value. And then if I start moving downward, I get a negative value from the green line, and I get a negative value from the red line. Again, we don't care what they are specifically, but what this now tells us is that I have positive value from the blue line times my 2 negative values from the red and the green line. These negatives multiply to be a positive, and positive times positive is positive. So I can label this whole interval as positive. Okay, hopefully we're getting the hang of this. So let's keep going. Let's pick this point here, right? Travel upward, I get a positive value from the green line. We know that this blue line will kind of keep traveling on forever and ever. Whoa, that is a lot going on. What did I do? Start hitting the back button. Okay, let's try that again. My blue line will keep traveling on forever and ever. And I can get a positive value from the green line, keep traveling upward, get a positive value from the blue line. If I travel downward, I get a negative value from the red line. And now, again, we don't necessarily care what these values are, but I know the blue line produced a positive, the green line produced a negative, or a positive, and the red line produced a negative. These 2 positives multiply to get positive, and then a positive times a negative is a negative, so I can label this whole third interval as negative. And then the last one will be the easiest, right? I can pick a point here. I travel upward, I touch the red line. This green line will continue forever, and the blue line will continue forever. And so if I keep traveling upward, I will get positive value from the green line, positive value from the blue line. And if I multiply 3 positive values together, I'm always going to get a positive value. And so this last interval is also positive. So this is a method of sign diagrams that might be a little different than what you're used to seeing, but we're taking advantage of this idea that we can kind of generalize the points being produced by each function, and then we can pick a random sample point and sort of analyze what's going to be produced by each factor. So hopefully that makes sense, but the last thing we have to do is we have to interpret this in the context of our problem, right? So we're not done yet. So the original problem is saying, when is this function less than or equal to 0? Well, what numbers do we know are less than 0? Those are all the negative values. So I want to capture in an interval all my negative values, and then for my endpoints, which are zeros, I can include them because we can also be equal to 0. So my final answer might look something like, well, let's pick our first negative interval. That's going to be from negative infinity to negative 2. And then I also can include my 0. So negative 2 is going to get a bracket because we can also be equal to 0. And then I want to skip a whole bunch of values in between negative 2 and 1 because those are positive. I want to pick back up at my next negative interval, which starts at 1. So I'm going to say union 1. And remember, we can include 1 because 1 is a 0. I want to travel from 1 to positive 3, which also gets included because 3 is a 0. And then everything from 3 to infinity is not included. That's all positive. So our final solution interval is going to look like this. And that was interpreted based off a sign diagram that we can make because we factored our polynomial. And that is a general method of how you would use a sign diagram to solve a polynomial inequality.